Alright, so in the previous part, we have been discussing how to start this word prediction task and also how to consider use this task to learn the word embedding vectors. So besides word prediction, we may also wonder, can we do something more aggressive? Can we generate the words instead? So besides completing the missing word, we want to do something more aggressive, like do the generation of documents with deep learning. So task we can start maybe something given some initial words as input. We can feed this one as input for some models. Then this model can generate one paragraph or even one article out. Starting with these words for us. For example, in this page, we show you with the example, like if we feed the model with the inventors have known these three words as three tokens or beginning tokens for the model, then we want to ensure the model can generate one article out, like inventors have known, dreamed of creating machines that can think. Then the task will be much more aggressive, also much more challenging, right? So can we do this? I think we have also briefly mentioned this task before in the previous part, right? So in project stage 4, we have one task is to generate some of the documents out, right? Based on the three inputs. In the previous section, we also mentioned how to build a model like this for generating this document, and we can feed these three inputs as the input for recurrent neural nets. So by building a recurrent neural net with three input portals, like this one, inventors have known, we can represent them as one hard coding into the recurrent neural nets, or we can represent as one unique IDs, as we mentioned before, right? How to represent the words. So by fitting them as inputs into a recurrent neural nets, then we want to generate the fourth word as the output, right? So given the three input words, we can learn their embedding vectors or hidden representations, right? This will be the hidden representation for the inventors. This one will be the hidden representation for have, given the context of inventors. This one will be hidden representation of known, given the information we know inventors have already, right? Because this one will receive input from the previous two, right? So in other words, part of the information in this hidden representation carries both have as well as some information from inventors, right? It will be similar for this one. This one will carry some information from known, of course, also have and also inventors. And based on this learned embedding vectors for the known as well given the context of inventors have, we try to infer the next word not dreamed as output, right? So by comparing the prediction with dreamed, this ground truth, then we can define one loss function for the prediction of the fourth word. And if you still remember in the previous section, we also mentioned how to further infer the next word right, after dreamed. So the way we do the inference of the next word is by fitting this prediction result, something we predict as input for the third portal, and we can also shift this input to the left-hand side, right? Then we can fit in the inputs as something like this: have known, dreamed. This have known is a given word, right? We have before. This dreamed is something we infer from the previous step, right? This is the prediction result by the previous step. And then we feed this one as input for the next round, and we further infer the next word. So both the dreamed of there will be the prediction by the model, right? And if we want to further infer the next word, we can also shift the inputs to the left-hand side again, and also apply dreamed of these prediction results as input for input portals as shown here, right? We have known to be the given word by at the very beginning. The dreamed of the prediction by the previous two steps. In this way, we can infer the next word, which would be something like creating, right? By the recurrent neural nets for generating this article. You can see, if we do the prediction in the very beginning in a correct way, then the generation process in the following step will be also correct, right? However, once you train a model, if you make a mistake in the very beginning, like if we have inventors have known, you make a wrong prediction for dreamed, then all the following prediction will be likely to be wrong, because if you have a wrong dream prediction in the very beginning, then the following steps based on the prediction result will be likely to be wrong as well. So make sure, you don't make much mistakes in the very beginning to generate the documents. Otherwise, you will be likely to generate something which are very hard to read actually. So this is the generation process, and we can shift the inputs slightly according to the prediction results, and we can do this prediction step by step, and also fit the prediction in the previous step as the input for the following steps. Then you may also wonder, how can we learn this model? How can we learn this model? So given the inputs as well as the prediction results compared with the ground truth, we can define the corresponding loss function, right? So this is the way we can understand about this model, right? You may also wonder, how can we do this task in training the model? When we do the training of the model, actually we can, given the document input something like this, we can partition the documents into some pairs. The pair covers both the three input words as well as prediction targets. Now, given one article, like the inventors have not dreamed of creating machine like that can thinking and something like this, we can partition this kind of sentence, all these words, into a set of pairs. This is the first pair. It covers both the 3 input words as well as the next word. Inventors have not dreamed, right? Given the inventors have known, we want to infer the next word to be dreamed. And this one can be serving as one training instance for the model, right? Similar for the next one, like have not dreamed, and we want to infer of as a prediction result, right? We can also serve this one as like a training instance for the model as well. Similar for the remaining. So in other words, when we do the training for the model, we can partition this kind of input documents into this kind of pairs, covering both the 3 input words as well as the target words after that. So in this way, we can represent this kind of documents into a training set, and we're going to fit the training set into the model for learning the model, right? And for each of the training instance given 3 inputs, we want to infer this output, right? And by comparing the prediction result versus the ground truth, we can define the loss function. So by summing all the loss terms for all the instances in the training set together, we can define the final loss function for the model learning for the text generation task, as shown here, right? This is y hat denoting the prediction by the recurrent neural nets, given the inputs. We can infer its output to be y hat. We can define the loss function according to the cross entropy, comparing y hat with ground truth y. And we can further sum all the instance loss terms together to define the final loss term, right? Then we can learn, the model by minimizing loss term, as shown here. So before we also mentioned, besides architecture like this, given 3 words, we infer the next word. We can also have some other architectures as well, right, which can also be possible. In this page, we show you 2 potential architectures. The first one is given 3 words, we can also infer 3 words. However, there exists one corresponding relationship among the outputs and the inputs, right? So for the inventors, its next word will be have. We also want to ensure its learning embedding vectors can be able to infer the word have as the next word, right? As its next word. Similar for have, its next word to be known. We want to ensure its output will be known as well as the prediction, right? Similar for the known, its next word will be dreamed. So in this way, given these 3 inputs, we can generate 3 outputs, even though some of them they have overlap with the inputs here, right? But here we sum all the loss terms for all these 3 predictions compared with the ground truth. And if we want to train about something like this, we can also partition the documents into the training set, right? Covering both the 3 inputs as well as 3 corresponding outputs, right? Some of them they have an overlap, of course. This one is to do a prediction of the next word. At the same time, we also ensure or force the model to be able to capture the sequential order for the first 2 words as well, right? As the prediction results. Besides this one, we can also have some other architecture, like shown as here. Now here, given 3 input words, we want to infer 3 words following them at the same time. Now inventors have known, dreamed of creating, right? So besides this dreamed, we also want to infer of creating at the same time, with this dreamed. So in other words, this one will be more aggressive, right, compared with the previous one. This one is to given 3 words, infer the next one. However, this one is given 3 words, infer 3. However, some of them they have overlapped with the training set, right? Training instances. We only infer 1 new word. It's a dreamed. When it comes to this one, given 3 words, we infer 3 new words, which are following this one, right? This 3. So, if we want to train model like this, we can also partition the training set of these documents into a training set. Given 3 words, we can have inventors have known as to its desired ground truth labels will be dreamed of creating, right, as output. So we can sum in the loss term together to learn the model like this. Then we'll be able to generate 3 words, after the input, at the same time. So compared with the previous model architecture, this one will be more costly because this one we have to generate 3 terms and we have to learn and we have to calculate 3 loss terms and sum them together. This one costs much more than this one, right? This one we have only 1 single loss term for learning the model. This one we have 3. However, this one will be more robust because here we want to ensure this embedding vectors for all of them will be able to generate next word. In this way, we ensure this embedding vectors to capture the useful information or patterns between the input and output, right? This one will also be much more costly. However, it is also much more aggressive. And in terms of generation process, it will be much faster, right? Because each time we can generate 3 new words. Then compare with this one, generate 1 words, then this one will be much more faster, right? Okay, so these are the potential architecture you can try to play with. For the project stage 4, you can also compare with them each other to see which one can learn better, also to compare the learning cost. according to my previous experiences, I mean, this tool will be cost more than the first one. I mean, it will be slightly slower, but however, this one will be much more robust, and this one will be much more faster in generation because it can generate multiple words at one time. Okay, so this is the generation process. We can also apply the recurrent neural nets to learn the embedding vectors for the words as well by starting this text generation task. So this is all the hidden neurons will be learn some embedding vectors for the input words, right? Like inventors, its embedding will be like this one, hair will be this one, and noun will be this one, the embedding vectors. Depending on which architecture we are using as well as which task we are studying, we can learn the embedding vector for the words in different ways, right? Okay, so this is the recurrent neural nets and how to apply the recurrent neural nets for learning the embedding vector for the words and for starting the generation task of documents.